In response to the declaration of a climate emergency, the following cuts must be made by the architectural industry as soon as possible, hence RIBA's declaration. 1. Cut operational energy use and emissions of carbon dioxide by at least 75%. 2. Before and off-site, renewable energy offset, 50 to 70% of the embodied carbon must be reduced. 3. Reduce the use of potable water by 40%. 4. Reach all major health objectives. Energy use, embodied carbon, and water use are the three environmental sustainability outcomes that this challenge is focused on, and all new or renovated buildings contribute to them. The overall objective is to target net zero whole life carbon emissions, or better, by 2030 at the latest. According to the RIBA 2030 Climate Challenge trajectories, urban areas with certified woodland offsetting and off-site renewable generation could achieve net zero whole life carbon, as could lower density areas without offsetting. There are outlined goals and standards for every outcome. Depending on the industry, building type and use, region, and other variables, target recognition will need to be customized. RIBA will develop metrics in collaboration with groups like RICS and CIBS. The emphasis is on project teams to strive for a percentage reduction of the current best practice benchmark and to contribute to developing sector norms in the future, because time is of the essence for the development of the ideal standard. These goals are challenging, but doable, and they mark an important first step towards a UK with net zero carbon emissions by 2050. The most recent recommendations from the Green Construction Board committees on operational carbon, materials, and waste are taken into consideration, along with comments from a number of professional associations and the RIBA Sustainable Futures Group. Target could be used as an example in homes and offices. To assist in the accurate prediction of the operational energy target and prevent the performance gap, RIBA advises using CIBS TM54 or other comparable tool for performance methods. It must indicate both the total energy consumption and the total energy consumption broken down into regulated and unregulated amounts, as well as the fuel types used. For the same reasons, in order to ensure measurement consistency and efficiency, RIBA suggests using embodied carbon assessment tools that incorporate all RICS whole life carbon modules A, B, and C. As tools for assessment, a number of POE and sustainability assessment techniques are available. Similarities can be seen instead of trying to imitate or replace them. They should be chosen based on the quality of insight and feedback they provide to guide briefing and design in the early stages, expectations management as a project progresses, performance assessment, and corrective interventions after a building has been used. They should be as direct as they can be and stick to constructive criticism. Complex statistical analyses may be difficult for designers and building operators to comprehend. If all available tools were put to use on one project, there would be duplication, inconsistencies, an abundance of data, and a higher risk of erroneous correlations between supposed causes and effects. It is best to maintain dependable and trustworthy input data, while keeping the outcome metrics straightforward. The most important outcomes should be the only ones defined, and project teams should be free to choose the sustainability assessment and certification methods that are best for their project and their client. Optional tools like BREEAM, BUS methodology, CIBS TM22, CIBS TM54 and TM59, CIC Design Quality Indicators, LEED, Living Building Challenge, Leesman Index. Neighbours, Australia, Passivhaus, RIBA Social Value Toolkit, and Well-Building Standard are also advantageous. The most important outcomes, such as zero operational carbon, zero embodied carbon, sustainable water cycle, sustainable connectivity and transport, sustainable land use and biodiversity, good health and well-being, sustainable cities and communities, and sustainable life cycle cost, can be defined using process tools like the RIBA plan for use and soft landings. We can no longer only rely on predicted values. In-use performance needs to be consistently and accurately measured and verified in order to close the performance gap and deliver reliable levels of sustainable results. The two most popular sustainability assessment tools, LEED and BREEAM, have greatly increased people's understanding of and capacity for incorporating sustainable design and technology. The performance gap has been significantly closed by BREEAM 2018 by awarding points for C.T.O 54 based energy use verification and post-occupancy user surveys. To reiterate, using metrics is essential. It is crucial to keep reviewing the metrics and methods throughout a project. The golden thread, connecting client and design intent with operational reality, will be maintained, as stated in the Soft Landings Framework and the Hackett Report. Post-occupancy evaluation. This evaluation is crucial during stages 6 and 7 of the RIBA plan of work to maximize in-use performance. Stage M feedback was originally included in the plan of work in 1963, but it was dreadfully underused and eliminated in 1972. This situation cannot continue, so all architects are required by RIBA to present POE to clients as a fundamental service. Level 1, light touch review, to get quick feedback on operation and occupant satisfaction, and to spot areas that could use improvement. The architect will ideally accomplish this with assistance from other design and construction team members during RIBA Stage 6 by the conclusion of the 12-month defects period. Although not required, some independent input is preferred. Level 2 diagnostic assessment, usually performed by unbiased evaluators in the second year of employment. This level evaluates any issues discovered, including those at level 1, and confirms performance. Independent evaluators will conduct level 3 detailed, forensic, investigations as necessary to find and, when possible, fix any significant and lingering performance problems. Although they can begin at any time, in an ideal world, they should be finished by the end of year 3. The building performance evaluation tools that are part of POE cover a wide range of metrics and outcomes. In the UK, both the BUS methodology Occupant Satisfaction Survey and the C.T.O 22 Energy Assessment method are frequently used. Both were created in the 1990s and codified after being used as models for in-depth studies of offices. They were used in the 20 probe POE studies that were published between 1995 and 2002, along with walkthrough surveys, handheld instrument spot checks, casual conversations with residents, and walkthrough surveys. In conclusion, Consumer Trading Organisation Limited will host more concepts moving forward.